Hello and welcome to our video today. So we shall be discussing limiting reagents and limiting an excess reagent, and then percentage yield. So a reminder, so for this chapter 14 and 15, you're not going to have a chapter test tomorrow right away. So that will be on Friday or on Thursday. I'll assign that to you so you'll be able to answer it. Now for your chapter test, it's going to be a combination of chapter 14 and 15, and all will be multiple choice and true or false, I guess. If there will be problem solving, it will be multiple choice, so that's it. Anyways, let's continue now with the lesson. So for percentage yield, this is a very simple thing. In reactions, not everything would be made. So some of them might be lost. It could be, for example, for water, some of them would evaporate into the air, meaning not everything is there already. You lost some of the moisture or some of the liquid. That's how actual reaction works. So to solve for the percentage yield of how much is made by percent, you have to do this. Actual yield divided by the theoretical yield and then multiply by 100. So the actual yield is a given, and then your theoretical yield is usually solved from your stoichiometry problem. So let's have a look at this. So this one is a problem that we've already solved. So the question for this item is this. If 196 grams of quicklime was produced in the decomposition, what is the percentage yield of reaction? So the theoretical yield was what you call this one taken from the last video of how we are able to solve this. So to solve for the percentage, all you have to do is actual yield, which is 196 grams, divided by 208.15 grams. So cancel out the grams, and then you multiply it by 100%, meaning your answer is going to be in percentage form. So 196 divided by 208.15, that's about 94%. 94.16% of the quicklime was created out of that 100, okay, out of that 500 kilograms of limestone. Now, if you want to pause and start to review it again, it's okay. Now let's go to the next one. For this one, still the same. And for this one, it says that, and it was able to produce at least 5 grams of water. So the actual yield that we have is going to be 5 grams. And then the theoretical yield, which was solved in the stoichiometric problem, is going to be 8.52. So to solve for the percentage, write down the actual yield, which is 5 grams, and then 52 grams of water. Cancel out the water, and then you divide 5 by 8.52, and then multiply it by 100. So if you do that, your answer is going to be, okay, times 100 degrees, which is going to be 58.69% of the water was created from that reaction. So that is a very simple concept, percentage yield, how to solve for the percentage of the given. Anyways, let's continue on now. So we're going to talk about limiting reagents and going to be excess reagents. This will be best explained by this. So let's just say your school had a program wherein there's going to be a pair dance-off. It should be a boy and girl partnership. However, in your section, you have 9 girls and you have 6 guys. Now, if you pair them up, what happened is this. You'll have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. The question is this. Who limited the amount of partners that would be involved? Is it the boys or the girls? Okay, of course, it's going to be the boys because there's just 6 of them, and you would not be able to produce more if you only have 6 of them. And now your excess is going to be the girls. The girls will be excess in a sense because there's going to be 3 girls that would not be able to dance with someone else. So for this given, okay, so if this will be in formula form, it will look like this. So the 9 girls pair up with 6 guys. This is your limiting, and then this is going to be your excess. This is where excess is going to go. So that's why you have 3 girls with no partner. Anyways, let's try to solve problems with this one. So before we go on, there is a way to do this. So the only thing that you have to do is convert everything into mole. Okay, what do you do next is this. You divide, you divide the mole taken from the mass, compare it with the mole from the balance equation. What happened next is you're going to compare, their answers. If the number from the given mass is greater than the ones from the stoichiometric formula, then A is going to be excess. This is where the excess will come from, and B will be your limiting variable or limiting reagent. Now, vice versa, if x and y is greater than a and b, then b is excess and a is limiting. Now let's try. So for this one, you have to convert everything into mole. So for this one, to find the mole of H2, in this formula, so for xy, this will be x and your y. This is 1. And then this will be a, and this will be your b. So for xy, let's solve for xy first. So x divided by y is going to be 2 divided by 1. So your for x and y, that's going to be equal to 2. Now let's solve for your a and b. So for a, so the mass for a is going to be 65 grams. Now what you're going to do is you try to convert it into mole. So 65 grams, I'll make it bigger. So 65 grams. Then you'll multiply it by your given. So H2O. I mean H2, just H2. So the mass of H is going to be 2.02 grams divided by 1 mole of your H2. You're just going to convert it into H2. So 65. So 65 divided by 2.02 is going to be, so that's about 32 point, so 32.178, which means we got 32.18 moles of H2. Now for the next one, you're going to use 350, so 350 grams of your carbon dioxide. So your carbon dioxide, carbon monoxide. So carbon monoxide is going to be 12.01 plus 16. It's going to be 28.01 grams of carbon monoxide, and that will be 1 mole for carbon monoxide. So cancel carbon. So 35 divided by 28.01. That would mean your given is going to be, is it 35? No, it's 350. Sorry. That is why. That explains. 350 divided by 28.01. So that's going to be 12.50 moles of carbon monoxide. Now let's try to divide this two. This will be A. Remember A, and this will be B. So for comparison, A divided by B is going to be 32.18 divided by 12.50. So 32.18 divided by 12.50 is going to be 2.6. Now, which is greater, A over B or X over Y? So this is 2, this is 2.6. Of course, 2.6 is greater. Now, remember, If A and B is greater, A is excess. So this one is going to be your excess, and this will be your limiting reagent. Okay, excess reagent is where it's going to come from, and then this is where your limiting reagent will be found. Okay, so again, limiting, B is limiting if, okay, if AB is greater than XY. So let's try another one. So this will be the last. So for this one, what is the limiting reagent between glucose and oxygen? So for that one, so we'll have C6H12O6 plus O2. Of course, in the given formula, you have CO2 plus H2O, and it's well known that this will be 6, 6, and another 6. This will be A and B. This will be X and Y. X and Y is going to be your coefficient all of the time. So, which is the limiting factor? So first, let's try to use both of them. So X is going to be 1. X over Y is going to be 1 over 6. So 1 over 6, 1 divided by 6, that would be 1.17. 1 point, oh, no, 0, 0.17 moles. Now let's try for A and B. So for A, you have here, okay, 14.12, 14.2 grams of oxygen, and no, 14.2 grams of glucose, C6H12O6. So what is the mass of our glucose? That will be 180.18 grams of C6H12O6. If you're confused with this number, it was solved from the last time. So multiply by 1 mole of C6H12O6. So that would mean 14.2 divided by 180.18. That's going to be 0.79 moles. Now let's try the other one. That will be 15.13 grams of your oxygen. So oxygen is 32 grams of O2. That will be 1 mole of oxygen. So cancel oxygen and grams. So 15.13 divided by 32 is going to be 0.473 moles. Okay, so now let's compare. So for this one, A over B. Now A is going to be 0.079 divided by 0.473. So 0.079 divided by 0.473 is going to be 0.167. So for this one is 167. The other one is going to be 1 divided by 6, right? So it's going to be 166. So if there's 166, that would mean A and B is still greater. Okay, this will be 1666666. So that would mean, okay, if A and B is greater, A and B is greater, A is going to be your excess, and your limiting is your oxygen. Anyways, I hope that you learned something from this video. This will be your, okay, limiting and then your excess. I bet you learned from this video, and see you on the next chapter as we talk about biomolecules. Bye!